Just by way of introduction, my name is Wayne Fishburne. I've had the pleasure of chairing this track for the last 6 years at Bio, and it's great to be here in Philadelphia again. For those who've not been here for the last couple of days, we started on Monday with a deep dive into digital therapeutics and some conversations about really how the intersection of digital health and traditional biopharma, it was emerging in the form of a creation really of a new category, which is digital therapeutics. And for those who didn't hear that set of conversations, it was really an interesting insight into any number of themes around the topic of digital therapeutics. But just to leave you with one notion, every pharmaceutical company, bar one or two, today have a major C-suite digital health effort in some manner or another. And the example that we like to use is if you have a blockbuster drug that's gone off patent, but you can in some way marry it with a digital story, then that combination creates, if you will, a new drug device, drug app, drug digital health tool combination that can reinvigorate the blockbuster drug with a whole new patent life, not to mention a whole new set of therapeutic implications. Yesterday we had conversations about what's happening in the ecosystem from an investment perspective, and then a interview yesterday with the new CEO of Quill, which again was a very interesting day. And today I think we start off with really a whole new look at some of the new technologies that have the potential to be game changers. And our moderator today, Sanjeev, will help us with the journey on that. But as we look at Bitcoin as really one of the newest opportunities, I'll just share a quick story that I have. So I've had the pleasure of serving on a Governor's Blue Ribbon panel in California, looking at cybersecurity as it touches digital health and healthcare devices. And John Madison, who is the CIO of the Kaiser Group and is really renowned in his insights and forward-looking, in our deliberations around this panel, Bitcoin was identified as really one of the most promising opportunities that he saw in the near-term future. And so, lo and behold, Sanjeev, who has been with us for going back probably, I would say, 5 years, helping organize the panel and the like, he has, and I'm saying Sanjeev. I apologize.
No problem.
So Sanjeev, who has been with us for the last many years, has really quite a notable career. 30 years in healthcare, now a retired partner from Ernst & Young, and has been a multi-time entrepreneur and has done a great job in bringing this panel together. So with that, I welcome you all, and I welcome Sanjeev to
Thank you, Wayne.
lead us. Thank you.
Thank you. Well, good morning, everyone. Thank you all for making the time to get here. We brought together an AI blockchain panel together. It's a emerging technology or set of technologies, and very few companies are undertaking both of those things. Mine is one. And I'll give you a little bit of background as to how we have taken sort of pieces at a time, and we'll go through that. So my company is Life Singularity, and we essentially are part of 3 different accelerators from Google, Amazon, and NVIDIA, which is an AI chip company. And we were actually very fortunate to have been selected by Exponential Medicine as one of the 500 startups to actually work in their healthcare innovation lab, presented last November when we launched. The idea that we could take data and be able to move that forward is kind of how we have. So, could you bring the volume up, please? And so we began to define what would it take to make health prospective. And in order to do that, I have to make it near real time. So what we have done is we have spent 3 years building the foundation, aggregating over 100 million patients' data. And these are all different health histories, very complex patients, 6,000 different diseases. Diabetes is 1,000 diseases, cancer is underlying inflammation, and so how do you capture all of these causalities and factors that impact your day-to-day health? But then, what do I breathe? Where do I live? How far do I live from the street, my context? and what are my exposure patterns when I go running on a beach or in a street. And we capture the neighborhood through drones, so we are capturing this daily environment, your ambient envelope around you, and so we could bring all of this data together. And then if all of this is available, how does that impact my emotional state of mind? So it's a pretty holistic view of what you undergo in your daily life, and could I make that frictionless? And if I can make that transparent to you and you become a contributor as a data source to us, so you're a living, breathing entity, and there's 10 million of you giving us this information at all times, we can begin to combine patterns that maybe work for you, potentially could work for somebody else. And there's a whole lot of discussion around HIPAA and privacy, but if you don't volunteer to me what your data is, how can I intervene? And so as we sort of thought about this, we began to say health could be near real time. Today we are at 0, we don't predict anything. I show up when I think I have a heart event and my heart is racing, I run to the hospital because it's here and now. But what if I could have done that 5 days ago? And so that's what we began to pull together as an ecosystem of your ambient data. And if I do that and combine that with millions of other entities, then I can define a future prediction about your trajectory. Then I can prevent, and hopefully from there we form this basis of changing the health equation completely. If I can save 10% of lives, that's 10% of 3 trillion. So as we sort of looked at, how we bring data together, we wanted to get to the precision of N of 1. And in order to be able to do that, I need continuous monitoring around your context. And to build a fully developed model, if you look at where our health systems sit today, they're heavily they're heavily an electronic health record model, right? EHR model or electronic medical record model. We have lab outcomes and things of that sort. What we don't have is the context of outside of a physician's facility or outside of a hospital. 80% of my life is at home, right? 20% of my context is genetic. So could I build a different context? And how do I do that if 80% of my journey is home? How do I build those blockchain smart agreements if I'm not in a continuous monitoring state? So that's what we have shot for in terms of bringing that context of an individual together. And from that, we have built this virtual assistant technology, which is now moving towards empathy and engagement in a natural way. And underlying all of this is data, and data is dynamic. We didn't want to just start with an EHR resource, although that's where we had to meet the health systems. But we wanted to start where we could also make this data dynamic and ever living. So as days go by and I get more data about you, I learn, the virtual assistant will learn. And over time, the virtual assistant will just become the assistant for you, right? So it's unique to you. So our goal as we went to market was to build a virtual assistant for everyone on the planet. That's our goal and vision. And obviously, as we now move towards integrating with you as a patient, I learned about your journey, how I engage with you. It's the way I would want to change the business model. We don't want to be in the same business model as where the health systems are today, where all of the data flows to them and I get nothing back. So can we change the model where I get monetized for what I share with you? Can I control what I share with you, right? Maybe it's used for research. Maybe it's used for combining my data with millions of other trajectories so that maybe a better cure could be found. That permission system doesn't exist today, right? We're signing off. Once we sign off HIPAA, we're signing off consent, right? And so part of what we wanted to do is put the AI in a new box, put the blockchain in a new box so we could build smart agreements around that. And that's the fundamental layer. But first, in order to do that, we had to be able to predict a trajectory. If I can predict, then I can preempt. If I can preempt, then I can prevent. And so bringing together Internet of Things, blockchain, and AI, that's the undertaking we have done. And we are able to predict these journeys at an individual level and be able to predict multiple trajectories simultaneously. So if you had, you're a patient with 18 diseases and 30 different drugs in your system, we have the capability now to predict all of those 18 journeys simultaneously. So I brought together a very esteemed panel here, and I'll talk through that in a minute here. I'll introduce each of my panelists one by one, and we'll focus on their work. And from there, we'll go down to, we'll open it up to discussion as we frame up each entrepreneur's work and my colleagues here. So to my right is Kamal Abad. Kamal is the CEO for Nebula Genomics. And Nebula has built a data sharing platform leveraging blockchain. Kamal has a background in computer science and bioinformatics, previously led a team at Google, and is a graduate from Cambridge. So welcome, Kamal. Thank you for making the time. So part of the journey, I'll play for you at what Nebula is trying to achieve. So, Kamal, maybe talk through what brought you to Nebula and the way you've adopted blockchain to go to market.
Yeah, so at Nebula, our goal is really to make genomics useful. We found that, so George, one of our co-founders, spent his entire career developing next-gen sequencing technologies, and he's a big part of why the cost has gone down from billions of dollars for one genome 15, 17 years ago to $1,000 for a genome today. But despite that huge price reduction, we've seen that genomics does not really play a huge part in healthcare, does not play a huge part in drug discovery. Pharma companies aren't really leveraging genomics that much, excluding the top largest ones. And a lot of it is a data issue. So there's a lot of genetic data that's available. 30 million people in the US alone have done some form of personal genetic testing. But the issue is that data is very sparse. It's not actually connected to patients. It's really hard to get all the contextual, phenomic, and clinical data that helps inform us how your genetics influences your health and the medicines you're taking. So that's the kind of data that researchers really want, is high depth, high quality for specific indications. So at Nebula, we're trying to build a platform where patients and individuals can be one of the main stakeholders in research. So instead of having to deal with de-identified data, data that you can't recontact or re-engage patients with, we want to build a platform that uses blockchain and other technologies to enable patients to own their data, decide how it's being used in research transparently, and also incentivizes them to share more and more data over time so we can build holistic longitudinal data sets. So you can start doing interesting things like developing personalized medicines, doing rational drug design.
Thank you, Kamal. So in terms of, as you thought about with genomic services, the way you went to market was predominantly around whole genome sequencing,
yeah.
Right? So talk through that.
Yeah, so a lot of the genomic data that exists today isn't actually whole genome sequences. So there's a few different technologies, right? There's genotyping, which is what like 23andMe or Ancestry do. And that's it's an older technology. It looks at around 0.2% of your DNA. And that's the vast majority of genetic testing that's been done today. The issue is there's another 99% of your DNA that we want to look at, that we want to understand how it works, what it does, how it influences your health. So what we've been pushing forward with Nebula Genomics is this whole genome sequencing. And the cost has come down so much that we're able to do low-pass whole genome sequencing for around the same cost as these other direct-to-consumer genetic testing companies. We think the way that genetic data has been generated also is a little bit backwards. So when it comes to clinical grade whole genomes, like 30x, high depth, really expensive genome sequencing, pharma companies or researchers love to get this data, but for them, it's really, really expensive to do so just because of patient recruitment costs. So the way we want to set up our platform is we can allow pharma and researchers to sponsor sequencing for patients. And then patients get access to their data, they get to benefit from their data, and they also get to share it with researchers. And this way we're bringing recruitment costs down. So this is something we're doing with pharma companies right now, is this idea of use our platform, our patient-owned platform, to sponsor genetic sequencing for patients, allow them to benefit from their data and get access to their data. And in return, you'll be able to use their data for research purposes if you get consent.
So is this targeted towards a certain set of diseases that you see as you've been sort of talking to the companies? Yeah.
So you can go to our website right now and get a spit kit, a genetic testing kit, and do it if you want. For the deals for the sponsored sequencing that we're doing with specific pharmas for specific disease areas. We think there's a lot of value though in genomes from people who don't. You don't need to have a rare disease or a genetic condition for your genome to be valuable to researchers. But a lot of the interest has been in specific disease areas from pharma companies.
Do you have an example that you can share, Kamal?
Sure. So a specific pilot we're doing right now that we'll be announcing publicly next week is around lung cancer with a large pharma company. So they're interested in understanding how one of their chemotherapies, it's working on some people, it's not working in others. They want to follow people over time and understand, is there a genetic component that's influencing how people respond to the treatment? So we're working with patients to collect genetic data, do even tumor sequencing, package that data and provide it to pharma, and then pharma are able to re-engage with patients over time and sort of understand how their disease is progressing and if there is a genetic component to how they're responding to drugs. And this could be, there's a greater and greater emphasis on using real-world evidence for increasing indications for therapeutics. And this is a potential application of that.
In terms of reaching, some of the things you outlined in risks or incentives for patients, right? At a patient level, the quality of data matters. And so talk about, the risk of reaching critical mass and how do you get there with the quality you want?
Yeah, so there's kind of two approaches. We're not the first company to try to build a valuable genetic health data set. And there's kind of two general approaches, right? You can kind of go for scale and low depth, which is what a lot of personal genomic companies have done. Or you can go for really high depth, but maybe less scale. And you can look at companies like Decode in Iceland that have done this. Both approaches have merit. What we're trying to do is really combine both, right? The way research has traditionally been done, you can look at projects like UK Biobank. When you participate or you give your data up for research, you almost never get anything in return, right? Frequently, patients are getting sequenced for studies. Just the way research frameworks are set up, consent is set up, patients cannot get the access back to their genetic data. So we want to build a platform where you do get access to all your data if you participate in studies. You're able to get re-engaged, and we can start building scale and depth to those data sets. So you don't just swipe a credit card, get a spit kit, get a result, and never re-engage. Instead, you have the opportunity to participate in studies, know how your data is being used, know that you have control over how your data is being used, and be incentivized to provide more and more information over time.
Yeah. I mean, one of the things we talked about was, is this, you brought it up and you said, personal genomics is like a safety belt.
Yeah. So I actually borrowed that metaphor from George. We think at some point in the not too far off future, everyone will have done whole genome sequencing. It's kind of like how mostly everyone wears their seatbelt, right? Most likely you don't need to wear your seatbelt, but there's enough percentage of time that you should be wearing your seatbelt that it's worth it. It's very similar for genetics. We think most people, if you get whole genome sequenced, you're not going to find anything immediately actionable, at least not yet. But there's enough percentage of people where it's valuable that population scale whole genome sequencing does make a lot of sense. So we've been talking to payers, we've been talking to healthcare providers. Everyone thinks this is the direction the industry is moving in, and it's just a matter of cost, and cost has been going down quickly. So we do think there is a future that's not too far off where everyone's done whole genome sequencing, where it's actually impacting your healthcare. And the question is, how do we build infrastructure to make sure you have ownership over this data, but are still able to share it because it's valuable to share that data, right?
Yeah, and we, the last point that Kamal makes around, use of this kind of data, we worked with a health system where they were looking across 4 different cancers and leukemia. and then Hodgkin's and non-Hodgkin's lymphoma and ovarian cancer. And these patients, they were trying to find out why some were responders and non-responders. And the idea of combining genetic data with the environmental factors and other factors in their lifestyles and behaviors is where we found the insight as to which genes, because it's population health, sometimes you eliminate anything that does not have p-value. And we were able to find insights where genes which were being thrown out because we thought, because of big data and the ability to use AI for that, we were able to find those insights. So as we move towards this new frontier, we'll be able to leverage all information available and not just what's statistically significant based on our current thinking today. I want to transition to you, Kat, and I'll introduce Kat and I'll play a brief video about what Kat's company is doing. So Kat is the CEO for Simply Vital Health. Kat was priorly an administrator, hospital administrator at Yale New Haven Hospital. She's now the president and CEO of Simply Vital Health. Her mission is to harness blockchain, the digital ledger technology at the heart of Bitcoin, to combat inefficiencies in medical record keeping and payment systems. As a former administrator, Kat did not find what she wanted to do that was available as technology, so she built the platform from Simply Vital Health. And this has a HIPAA-compatible protocol, Health Nexus, that Kat will touch upon, and which is also a blockchain protocol to aggregate data across the ecosystem. So let me show you what Kat is doing.
Healthcare is moving toward bundled payments, yet healthcare providers are in the dark about what happens to patients when they leave the facility. 73% of variability in Medicare spending is due to utilization of post-acute care, and 49% of costs in orthopedic bundles happen in post-acute care facilities. Providers at different facilities struggle to communicate and don't find out the cost of the patient's stay until months later. This leaves providers in the dark about projected savings or penalties, and it's difficult to ensure patients are getting the right care. Enter Simply Vital Health's platform, Connecting Care. Connecting Care allows the entire care team to follow the patient and communicate instantly with providers at different facilities. Our financial forecasts give near real-time estimate of costs so providers can manage towards savings. Our platform is backed by blockchain technology to provide the most secure HIPAA-compliant protocol on the market and secure audit trails. We want to empower providers to thrive in the value-based care model, so it is vital that the future of healthcare becomes simple. Simply Vital Health.
Sure, it's fun to send your...
So we'll come to EncryptGen next. Kat, welcome.
Thank you.
Talk a little bit through what drove you towards data access and building the blockchain protocol that you built.
Yeah, so as a hospital administrator, I was managing what's called a bundled payment program, which is essentially a capped reimbursement for a specific amount of time. And what happens is that the clinician who treats the patient first in this bundled payment is responsible for the care of that patient no matter where they go for 90 days. Mm-hmm. But the difficulty is once the patient transitions out of the hospital, it becomes a black hole of information for the provider. They don't know where the patient goes. And any care that happens to that patient, they could have been there for a hip replacement, but then they break their arm. That first provider is financially responsible for that patient. So once we actually were using a vendor in the space at Yale New Haven, canceled the contract with that vendor, and in the process of trying to find something that fit our needs, there wasn't anything in the market. And so I had identified all of the opportunities around the weaknesses and how we could make this whole situation better for healthcare, and then started Simply Vital Health to fill that gap.
Fantastic. So, we will go back and forth a little bit today. You heard from me why we are trying to do NF1. You heard from Kamal trying to get down to the individualized genetic analysis. Kat has a different perspective on where blockchain needs to go, Kat, so touch upon that.
Yeah, so we're really focusing on the health system first, more of the enterprise, and there's a couple of different reasons for that. One is I'm a Teach for America alumni, and I served on the Texas-Mexico border. And while I was there, I had students who didn't have electricity, they didn't have running water, roofs over their houses. They were US citizens but weren't recognized by the Postal Service. So often the last thing that they were concerned about is their health. They were more concerned about how are they going to make living paycheck to paycheck and how are they going to feed their family. So when you really look at the healthcare system in the United States, a lot of what we see are companies tackling healthcare for that top 1%. Those that are really healthy anyway, those that buy Fitbits, those that are really interested in their healthcare. But when you look at the highest utilizers of healthcare and those that really need healthcare, it is a lot more of the profile of my students on the Texas-Mexico border. And the best way to help support them is to help support the system. That's how Teach for America does it. As an educator, it was very difficult to teach 7th grade science while realizing that my student was in and out of the hospital for different surgeries, and the last thing he was concerned about was his education. So when you look at the whole population, we're really focused on more systems changed, which will then trickle down to the individual. The other perspective of why we focus on specifically bundled payments in value-based care is because the same in Teach for America, when you have these really complex systems, you want to focus on what's within your locus of control in order to drive change. When you look at value-based care or being able to pay doctors for outcomes, there's a lot that they're accountable for that's not within their locus of control. Diabetes is really difficult to control if you're a physician, when 80% of your health is based on what you put inside your body. So we focus first on bundled payments because it's a defined recovery in a certain period of time based on a surgery or diagnosis. And it does allow a certain level of autonomy to the physician, which then helps to create that systems change, which does eventually lead to not only financial savings, but better outcomes for the patient.
So financial savings, right? So talk through, how many thousands have you been able to put forward?
Yeah, so based on our platform that we have, it's actually shifted from more than just a platform connecting care to more comprehensive care. We have everything from care coordination to financial analytics, and a platform that follows the patient regardless of clinical affiliation. Based on this program, we've been able to drive savings of anywhere between $4,500 to $5,000 per patient, which is the highest in the industry.
Awesome. So as we looked at your capabilities, I mean, you heard me talk about HIPAA. You heard Kamal touch privacy, and blockchain is about privacy. Talk through the HIPAA compatible, the Health Nexus piece.
Yeah, so HIPAA is a necessary evil and beast that we're all facing in the blockchain space, blockchain and AI space. So we've decided to, I think we're all kind of very similar in that this is a long journey. So what we've decided to do is work with HIPAA now, and then collectively as an industry, hopefully we can shift policy change that's more favorable to AI and blockchain. But what we've done is we knew that we wanted to leverage blockchain as a tool in healthcare, but there was no protocol that was safe to use and safely adoptable by healthcare specifically. We looked at a lot of different protocols. We believe fully in a public blockchain. We think that while private blockchains are helpful right now, that's more of the intranet version of the future, more beneficial internet, if you will. And so we really just went straight to that public permissioned direction. And basically what that means is we anticipated that, so we have a protocol, anybody can build on top of it. So let's say that an entrepreneur has built on top of Health Nexus, and they go and they speak to a health system administrator, myself, and I ask a lot of questions about security of their app. How does it work? What do you mean to use blockchain? Where do the servers sit? And if the entrepreneur is not able to answer that question, which you can't with most public blockchains, I don't know where the Ethereum servers sit, that then becomes a non-starter when you're speaking with large health systems, pharmaceutical companies, or health systems. So what we did is we created a public permission chain. We call it HIPAA compatible because HIPAA was not written with distributed ledger technology in mind, so you can't comply with HIPAA. But it's compatible in that we know every person that runs our network. We have around 21 individuals across the world that are running this network, which is actually in direct parallel to the number of individuals that run Ethereum at any one time. Despite all the thousands of people that you hear that run Ethereum, it's really only between 20 to 25 that contribute to the protocol. So we have 21 individuals across the world. We know who they are. They're hospital administrators, entrepreneurs, students. But the biggest differentiator is that to run the network, you must have a HIPAA-compliant computer or HIPAA-compliant server. And it doesn't mean that PHI or personal health information is going to touch that particular server. It just means that when the entrepreneur who builds on this protocol can answer the question, I know exactly who runs the system. And in fact, I've met the hospital administrator. He works at Einstein, and he's very interested in blockchain. We actually do have an Einstein hospital administrator that supports the protocol. So we really wanted to make sure that in order for healthcare to shift into leveraging blockchain, that they had a safe protocol to use. We needed it anyway. Nobody was building it, so we built it.
Great. So as we unfold the next few years into this, and to bring you back to the patient, we talked about retrospective bundles as they exist today. It would be nice to move towards prospective payments. So talk through the challenge of that a little bit.
Yeah, so a retrospective bundle is essentially how we know value-based care today, which is the patient moves through the system and all of the providers get paid after looking back at quality outcomes and the patient trajectory and the episode. All of us in healthcare want to shift to a more prospective model where as the patient is moving through, that quality is assessed in near real time and payments are distributed as the patient goes. There are a lot of issues with prospective bundles and prospective value-based care. One is legacy technology. There is a way to leverage blockchain and smart contracts specifically to create a prospective value-based care system, which as the patient is moving through, those awards, those financial incentives are provided to the provider and patient as they move through the system.
Thank you, Kat. And thank you for your work. One of the things the work we are doing at Life Singularity is to be able to predict the cost curve, right? And so if I can predict all 15 diagnoses and where your journey might be in the next few weeks, months, or years, then I can also attach a cost curve to that. And so if I know your cost curve is rising or falling, then I can begin to now understand, outcome, a drug is 11% of the outcome, right? So could it be the other 89% comes from somewhere else? And that allows us to now begin to map out both a financial outcome as well as a clinical outcome. Transitioning to you, Dave. So let me introduce David Kopsel. David is the founder and CEO for EncryptGen, a blockchain-driven DNA marketplace. He's an author, philosopher, attorney, retired, and an educator. And his work has taken him across science, technology, ethics, and public policy. And the reason we brought this sort of panel together is blockchain touches, it's a fundamental shift of business models and a lot of cross-connect across different, it's a multidisciplinary view of the world. It's not just about the technologies, what it's going to do to your business model. And ethics is a very important question as we shift from, as you'll start to hear now, as we go from privacy models to if I don't donate my data or don't figure out where my data is going to go, I have to volunteer my information. And so there is methods now through facial analytics and other models where you don't need to divulge your full identity. It's recognizable through other means. And so that's kind of the shift, and those are the reasons we bring ethics and public policy into this. So David he's an author of a number of different books on genetics, ownerships, and ethics of these things in terms of value of genomic databases and ability to protect donors and stakeholders. Is well published as well as on multiple forums in terms of working with Mexican entities as well, and he'll talk through that. So let me play for you what EncryptGen is doing.
Sure, it's fun to send your DNA off to a lab to find out more about who you are, where you come from, and who your ancestors are. But did you know that most genetic testing companies now retain your results for themselves and have the ability to resell your genomic data to research and development companies? It's true, and it's putting profits into the pockets of everyone but you. EncryptGen wants to change that. EncryptGen is a genomic blockchain network that provides customers and partners with best-in-class, next-generation blockchain security for protecting, sharing, and remarketing genomic data, creating a fair marketplace for your DNA. You can store it privately and decide who you want to sell it to, if at all, and for how much. You can also share it privately and securely with your physician for your personalized care. And EncryptGen is putting the power of your DNA back in your hands where it belongs.
So as we sort of looked at David's work and we're transitioning slightly from a for-profit set of ventures in blockchain to a social venture, set of social ventures in blockchain. And both David's work and John Kamara's work is going to lead us down a little bit in that path where we now put patient in terms of a clinical value chain, also make it patient-centric for financial value. And so the work that David has undertaken, David, talk about where you're going with.
Sure. So is this mic working? It is. Thanks. There we go. There we go. So one of our co-founders, my wife actually, is Dr. Gonzalez, and she's a pharmacogenomicist, and she works for the Mexican National Institute of Genomics. One of the incentives behind what we were trying to create was to be able to give a greater share of the value of genomic data back to individual subjects, and to simultaneously create a new pool, a new wealth of data that we could draw upon. So the way we created our platform was to try to firstly approach the nearly 20 million people who've already done genetic testing through these services that we've mentioned, and get them to start recognizing that there's value in that data, to open up that data to researchers of a different type. So we've talked about pharmaceutical companies, et cetera, but we're finding with our platform that university researchers who may not have deep pockets can easily buy, a part of a Bitcoin and come to our platform and start to find data for their studies. And this solves a problem that I used to talk about. My good friend Kevin Noonan and I first met 10 years ago when I wrote the book Who Owns You, and this was about why we shouldn't have patents on raw genetic data, isolated, as Kevin would point out. But one of my concerns was to avoid the Henrietta Lacks scenario.
Yeah.
So somebody who's given so much to science, who goes unremunerated until the NIH decides to fix it post hoc, we can solve that by recognizing that there's a huge market for the data, and by putting the people who have that data in charge of that data and able to sell it directly to researchers of any kind. And that's really how our platform is working and generating transactions.
So, the long-term platform, the quality of data matters to you as well.
Absolutely.
Right? And so talk through how you're encouraging incentives for that model.
Good. So, we're sort of all, I think everybody in genomics recognizes that when it comes to genomics and personalized medicine, we're all still Jon Snow. We really know nothing at this point. We've got to get a lot more data. And all of these efforts we're talking about here today, and efforts that are going on worldwide, are meant to try to get more data so that we can start to use tools like AI and mine it for deep knowledge about our abilities to serve your personal health care using better genomic data. Now, over time, we need to have whole genomic sequencing data in order to get the sort of precision that we're seeking. But as has been pointed out, it's still very costly. We've got to figure out ways to subsidize it. Nebula's model is to have pharmaceutical companies, the buyers, basically subsidize it. Our current efforts are focused on the payers, health care insurance providers, who are also very curious about the ability for genomic data to reduce costs in healthcare. And there's a good sense that this will be the case eventually when we have really good quality whole genomic sequencing data, and then all of the science necessary in order to use that for personalized care. But we're still building the Large Hadron Supercolliders. We've got to get that data first before we start to do the math and figure out what that's about. So we think that insurance providers have a large incentive, and we know this is true because they're already we're involved in a research consortium that will be gathering that data to prove this case to them using about 100,000 patients over the next couple of years, and we'll see. you know,
Yeah.
if it's worth the cost. We believe it is.
Yeah. So you're giving, 90% of your revenue to the end patient, right? The 90%, the remuneration.
It's
for,
the patient's
yeah,
revenue as far as
yeah.
we're concerned. So it's your data, you own it, you should get the lion's share of it. We're facilitating the transaction, we take 10%. We have in our blockchain the ability to provide different business models with partners using that blockchain and pay them directly through our blockchain.
Right. So as you put this together, the demographics that you were trying to go after and the people, so Kat mentioned earlier, folks who need the care the most, right? And it's not the ones who have Fitbits and Apple Watches. Those are the known, right? They know what to do. Talk through that and the work in Mexico that you've undertaken.
One of our partners is Código 46, which is a Mexican genomics company, similar business plan to 23andMe. They partnered with us early on, recognizing that they believe, as we do, that individuals should own their data. They shouldn't have it resold without their permission. And we think that this is actually a really important way to expand the pool of data. Right now, there is a real crisis in the fact that most of the genomic data that people are working with for basic science, 80% is from European whites. So this is not good for the future of precision medicine.
We need diversity.
We need significantly more diversity in the data. And we think one of the great incentives is to actually pay people directly for providing that data, and that's what we think is going to draw new businesses, new models of medicine in the developing world, and get that data into our basic science while paying people directly for it. There was a study recently that if everybody who'd done a 23andMe test had been paid directly by the companies that bought it, they would have gotten an extra $130. That was before the GSK deal, where GSK poured $300 million for exclusive access over the next couple of years into 23andMe.
Right. Kamal, you mentioned Decode Genetics before. How are you addressing diversity in data?
Yeah, so we want to make sure people can get sequenced without having to purchase sequencing. So the big issue right now is a lot of genetic reference data sets are based off of people with European ancestry. So when you're calculating things like polygenic risk scores, for instance, those aren't accurate if you're not you have European ancestry. So what we want to do is allow, like I mentioned, sponsored sequencing, right? Where you can go to populations that historically haven't purchased genetic testing, haven't gone through these direct-to-consumer genetic testing brands, or haven't done whole genome sequencing because it's $1,000, and you can still offer sequencing for free.
Right, fantastic. David, in conclusion, as you sort of looked at the rate of adoption, and you decided to go towards this marketplace model, right? So why did you decide to go to a marketplace?
Well, one is that we're not in the business of selling kits, but there's a lot of data out there already, and we saw two needs. One is for individuals to be able to profit from that data, and we see a intensifying concern by the public about others selling their data for their own profit. So that was part of our business model, was to allow those people to access that wealth themselves. But also because we think that if you have a free market, the real price of the asset will emerge.
Right, so we'll know what your genetic data costs.
Yeah, we don't know what it's worth right yet, but we know people are paying a lot of money for it. So why not create a free marketplace where the laws of economics can sort out the actual price of that data?
Yeah, so Wayne earlier touched upon Bitcoin, right? And you had certain decisions to make as to what currencies to adopt, and you adopted Bitcoin as a fiat, right?
Well, we created our own cryptocurrency. It was a freebie for us because we have a permission blockchain built on multi-chain that allowed us to create a cryptocurrency for free. So we called it DNA, and that's partly a branding decision, but it's also a mechanism of settlement on our system. So we can allow people to get paid directly in that and then cash it out to Bitcoin or Ethereum, and realize, money that, they can go to a kiosk around the corner and withdraw their Bitcoin and buy a loaf of bread or whatever with the profits they made from their data.
Awesome. Thank you, David. So John, I'll introduce John Kamara now, and John is flown in from Africa this morning, so thank you, John, for taking part in this panel for us. So John is a founder of Alpha Health, and he's also director of the Machine Intelligence Institute of Africa. John is an executive with sort of multiple experiences in digital economies in UK, Europe, and EMEA, Europe, Middle East, and Africa. He's an advisor to a number of different AI and blockchain projects in Europe and Africa, and has developed the Blockchain Center for Excellence Education in Nigeria in partnership with iTex. He's also the founding member of Jamboro, and Jamboro is essentially an AI-driven financial platform, which is for financial inclusion in West and East Africa. And he's also a co-founder of Afrimart, which is an intra-Africa trade platform. So the reason I wanted to have John part of this conversation, because John has many lenses. So he's looking at e-commerce, he's looking at financial trading of data, and as well as building towards health. So John John's work has sort of touched many different domains. So John, why don't you talk about where you're taking direction for health?
Thank you very much. Health for me, it's a lot of very smart people talked about some very impressive stuff. But for me, it's just a really basic problem that I'm just trying to solve in Africa, where I come from. And it just basically starts from a small story. I grew up in Ireland. I lived in Europe, Asia, South America, and I moved back home 4 years ago because I felt that I could do something better back home as an entrepreneur. Hence, trying to build different types of enterprises using technology. So for me, technology is just a resource to achieve an end goal. So blockchain, AI, it doesn't really matter. But with the health part of things, a couple of months ago, a friend of mine died. Really good friend of mine, very close. And we got the call in the evening that he was dead. It was quite hectic, pretty painful. So we tried to investigate why did he die. He's 41 years old. There's nothing wrong with him. All of a sudden, he goes to work in the morning. By 4 p.m., he's dead. And he died in the hospital in Nigeria. So we went to the hospital. We spoke to the nurses. And we found out for the first 2 hours, they just treated him when he was unconscious because he's diabetic. So he came to the hospital unconscious. They treated him for malaria, and they treated him for everything else. And 2 hours later, he was in a coma. So by the time they figured out, somebody came from home and told him that he's diabetic, you should give him insulin. It was over. He was dead. So there was no reason for him to die. It's a very simple problem. Just give him insulin, and he'll be fine. He'll be on his way. He'll be back to work, and he'll be here with us. So we started researching a little bit deeper into a lot of causes of deaths in the African continent. We chose a few countries to look at why do people just go to hospital and die, or just somebody is just dead. And then in the rural areas, and so we found the problem of death by misdiagnosis, which is a major issue in emerging markets, and Africa especially suffers from that. And what's the reason for death by misdiagnosis? Because there is no, you guys are talking about different types of structured data, whatever. We're talking about no data.
Right.
So there is no
Very
regulation,
yeah.
There is no data, there is nobody to fight. The problem is, can you just find some data, first of all, before we even start arguing about what that data means or whatever. So we took that approach that, okay, look, if we're going to try to solve the problem of health in Africa, we have the opportunity to start from scratch. And we don't necessarily have to look at the Western world, the way they've done theirs. let's find our own solutions that work for us, because we've got our governments have bought, Central Health, Epic, and all this, but it will never work because we don't have the infrastructures. If you've ever been to a rural city in some tertiary city in one country, Malawi, you'll understand that there's no way there will ever be a central health system that connects to any grid. But what we all do have is we all have the mobile phone, all of us. Loads of us have mobile phones. We probably use the mobile phone better for life every day than people live in the Western world, because our life is tied to the mobile phones. So financial inclusion in Africa is tied to mobile phones. Education now is being tied. So can we also use the mobile phone to begin to address the problem of health data? And then we also found out, the first 30 minutes of death in a number of African hospitals is caused because of lots of data.
30 minutes.
First 30 minutes. That was very, very profound information that we got it from a lot of the research, because we work with a few different young doctors who were also trying to solve the problem. So I come from an entrepreneurship technology background, and my views always, and we spoke into lots of NGOs, donor organizations, grants, the UN, to everybody who's been doing intervention work for the past 20, 30 years, and great work, but not lasting. Once they leave, the work is over. Then they start another program, and then another program, and billions of dollars later, we're still where we are. So that's not going to help us either. So we need to create commercially viable social impact enterprises. They have to have money behind them. We don't have to wait for this. So we have to back entrepreneurs who are creating social impact projects. So that's where we started the idea to say, why don't we create a very basic platform, not super, that allows the users to be the ones collecting the health record. When they collect the health record, we store it for them, and then we begin to incentivize them to begin to add to their health records. So that gives us, so you see, it's not just basic health record, just blood type. What is wrong with you? Have you ever been to the hospital? Take a picture of the drugs that you take. Really, really simple stuff. We store it in a structured format, and then we start getting you to store unstructured data day on day. And we focused on women, mothers, we call them our mothers in Africa, the ones who basically handle the house, they handle the kids, they will handle everything. They're also the ones who are very involved in the informal economy. And so we did a small research group in Uganda, and what was very profound was when we went to this little village and we were talking to the women, and they told us that Doctors Without Borders come every 3 months for the past 7 years. But every time they come, after 3 months, they have to start all over again. So, and everybody gets 5 minutes with the doctor, because they touch you, they feel, and then they're gone. They give you some drugs if you're sick. So we talked to the director of the Doctors Without Borders and said, okay, what is your biggest problem? And he's like, we just don't have any data. We just nothing we know. I mean, we give these people pieces of paper. They have to hold it for 3 months. And when we come back, some of it is lost, it's torn. Okay, great. So what if we're able to get this person to just enter very basic data and every day begin to enter unstructured data? It's not that structured because some of them are not very intelligent. And we begin to map this data with a lot of keyword maps. So for you, you can sit in Istanbul or Germany or whatever, and you can actually be live interacting with that patient. And they also know that you know that. So the light bulb moment in one of the women, when she thought about this could happen for her with her feature phone. So we do it on app and also USSD, something so you don't need data. You actually don't need data as in, to be able to access the platform and participate in your data, because we have to deal with our own real issues, which is a lot of people don't have connectivity. So we have to find other ways. Same way we work in financial services. And then with that, obviously, we're then able to incentivize the people. So we started speaking to the NGOs as well, who spend a lot of money in health education, health knowledge, from America, USAID, everybody. It's all the same thing. We've done tons of research documents. So health education, but we still get back to the people, and it's always lost in between.
So this is AI underneath.
Yes.
This is AI to take a lot of the self-diagnosis.
Exactly.
Data.
No, but what the idea is really to incentivize the patient to be able to actually start using it. And then the unstructured data with blockchain, that allows us to be able to verify information based on particular trends that we see that allow us to help solve some of the epidemic and outbreak problems that a lot of organizations take so much more time to build. So basically what we're building is a database from scratch driven by the users. And yeah.
Very good. Very good. In terms of the, you mentioned a couple of problem sets. So, I mean, if I compare you to where US is today, we have 100 EHRs and we can't integrate data and you're leapfrogging. In fact, you say it's a simple system, but only Apple is attempting something like a personal health record, in the US, which is what you're trying to do. And maybe the dearth of resources on the data was not such a bad thing because we have to be backward compatible in order to move forward. You have nothing to go back to. You just can move forward. So there is a key insight there as you attempt this challenge.
So that is a key for us. That there's nothing that we have a benchmark against. There's no. I mean, again, we've seen a lot of companies, governments have tried to use central databases, bought from the West and everywhere, but it doesn't work. And 80% of the people in most African countries live in rural secondary cities, and so those people, you have one doctor to 47,000 people. So effectively, it's impossible for even the doctors to be able to even see patients enough. So, and growing up in Ireland, I have a doctor that I saw till I was X amount of age. So they have some structure of my data. People, even if you're wealthy, you probably see 10 doctors every year because you go to whatever doctor's available. That's because you're wealthy. So imagine the people who make up the rural economy. So it's the same module, and so we tested, we tried a little demo product that we built, and with the incentive, with the way that we approach the consumer market, understanding the psychological behavior of our people, which is a little bit different. I mean, in our first demo, we had about 7,000 people in days. Basically.
So this is like a pre-qualified smart contract
absolutely.
that you're putting in place.
Yeah. Right. So and the last part of it is the fact that when we then went to Congo DRC, which is what I was telling you guys earlier on, we found that when Ebola broke out, obviously most people didn't know this. It's from day 0 to day 1 it was actually 62 days. Day 1 is the day that it was properly reported, but day 0 is when patterns started forming. But until a pattern formed that is reportable, you don't report it as an outbreak. Yeah. But with our approach and unstructured data with blockchain that allows us to verify information within a particular radius and geotag things, and then adding AI, we can actually pick out patterns. So we actually encourage our people to give us unstructured data, and we build a number of keyword maps into our blockchain. So we don't necessarily have to use a full blockchain. We just use the models within a blockchain that meets our needs.
Thank you, John. Thank you.
Thank you.
So James, last but not the least, but what I wanted to bring together with James is a principal partner at Ernst & Young, and he's the global part of the global blockchain team there and part of the risk advisory group focused on life sciences, regulatory quality and compliance. And James functions in the role of helping clients understand new technologies and applying them to real world problems. The blockchain problem that James focuses on is within the pharma supply chain. So as you sort of heard these different use cases, I mean, how do we bring this all together? Because underlying this, you have to sort of have the metadata as the drug gets built, gets transitioned to a provider, eventually prescribes it, ends up in a patient, or maybe not. Maybe there is a lot of issues around fraud and abuse and all of those things. So what I'll do is I'll play the video, James, and then I'll bring it to you as to where you're taking this.
Blockchains can be used in different ways. At EY, we tapped into the tremendous value in using the blockchain to track the movements of assets through the development of our Ops Chain solution. We use a special type of transaction to create a non-fungible digital token that is uniquely tied to an asset in the real world. In the case of medical devices or pharmaceuticals, this token represents a serialized unit or a batch of drugs. The token is created by hashing data that is unique and specific to the product it is representing. These properties are intrinsic to the token and remain static as the token moves from location to location, or blockchain address to blockchain address throughout its lifecycle. However, tokens can also carry dynamic properties, such as unit cost, which can change as the token passes through certain addresses and value is added to the physical good. Just like in real life, it is beneficial to move tokens in large groups, the same way we would ship a batch of products on a pallet or in a container. In blockchain, we use a special type of structure to collect tokens, and that collection can be moved as one unit. By looking at the collection, we can easily tell which tokens it contains, and because blockchain captures data in a common time series, any transactions that are done at the collection level are also associated to each token within. We can easily move tokens in and out of collections as our physical goods are either aggregated or deaggregated. All of this gives us incredible visibility into our inventory movements. By simply scanning the network, we can easily tell exactly how much of which inventory is at each location, who owns it, and what it is worth. Similarly, if we are interested in a specific product that has been tokenized, we can pull a log of all the transactions in which that token has been involved. And since the transactions stored in a blockchain are immutable, we know that the log accurately reflects what was recorded at the time of each transaction. In some cases, we may combine two or more products in such a way that their intrinsic properties are permanently changed, such as consuming a raw material to manufacture a finished good. In blockchain, we can use tokens to record such consumption by moving the source tokens into a common location, destroying them, and minting a new token with the combined properties. In this way, the blockchain maintains a record of what materials were used to produce a specific batch of finished goods. Similarly, we can assemble a finished good out of individual parts. In this case, the tokens are not destroyed, but become linked to a parent token that represents the sum of the parts. Those parts could, at a later date, be replaced by other parts, and the blockchain would keep a record of current state as well as all of the swaps. Finally, certain transactions can add data elements that may be important to the token, such as batch records or environmental factors. These get associated to the token at a specific location at a specific point in time. Collecting these elements in a log allows us to paint a picture of all the things that were associated with that asset along its history and how it got to where it is today. Through the combination of designing locations and tokenized assets, we can use the blockchain to clearly track the movement of goods as they change hands, and we can also understand the accompanying financial transaction that occurs. Using bits of logic embedded into the blockchain called smart contracts, we can govern the transfer of assets between two parties at the individual transaction level, in some cases eliminating the need for reconciliations and interfaces between those parties. This will allow organizations to broaden their network of business partners, optimize the flow of assets through that network, and have more visibility around the end-to-end life cycle of their products. By relying on blockchain to connect the network, we can also reduce our IT complexity and increase the integrity of our data exchanges. If we take advantage of all the ways tokenization can improve the supply and distribution of goods, EY believes blockchain will help create a better working world.
So, James, walk us through the compliance life cycle and the way you're approaching this in terms of some of your customer base.
Sure. Yeah, and I know in that video, apologize in advance, there's a lot to unpack in there.
Yeah.
But the part that I really want to emphasize, and the part that I've been doing a lot of my research and my team has been trying to contribute around, is this idea of combining tokenized assets and smart contracts with public blockchains that allows us to create all different sorts of business models. And we're getting to become pretty good now with constructing these tokens and these flows. What you see on the screen here is just an example of being able to use that to actually track assets as they change from blockchain address to blockchain address, which also effectively transfers custody or ownership in certain cases. One area that we've been doing this with, there's a few articles out there, happy to share some links, is with Merck Animal Health. We found that the animal health industry is very eager to kind of get in front of some of those technologies, and in some cases it's a little easier to be innovative there with how we're tracking our assets. And we're using it to track vaccines that are used to treat pigs and chickens, things along those lines. There's been lots of challenges. You know, two years ago when we first started kicking around the idea of using blockchain to track serialized assets, we thought, oh, this is going to solve serialization, it's going to solve DSCSA, we'll be able to track everything, interoperability will become trivial. Turned out not to be so trivial. It's very hard to get the participants all along a distribution chain to want to participate in something like this because of the visibility and access that it creates.
Transparency issue.
Yeah.
Right?
So what we've been finding with the animal health pilots is that we can actually get the farms or the veterinary clinics to participate, and we can capture the endpoints. So we can track things as they're produced and through manufacture. Maybe we can't get all of the wholesalers or shipping companies to participate, but we can now ultimately see when some of these drugs or vaccines are consumed, where they're consumed, and by who. And as we start to build out the scenarios with those asset tokens at the base to do things like ownership or financial incentives, there's a whole world of possibilities that that this lets us do without having to integrate all the underlying systems, which is how we have to tackle things in today's world.
Right. So when Kat was talking about the protocol that Simply Vital built around HIPAA compliance, right? You are doing something which is even pushing the future further into non-fungible tokens and self-sovereign identities, right? And how do you manage that? So talk through where the future of blockchain is evolving.
So similar to Kat and Simply Vital's stance on public blockchains, EY is a big believer that they have to be public, right? That's really where you get the value of it. That's really where we see the direction going. Current state, small private blockchains are easy to experiment with. They're great to get your feet wet with, but ultimately you lose out on so much of the value if it's not public. But that then brings up the issue of the privacy.
Yeah.
And the example I was just laying out, even with tracking vaccines, manufacturers or end consumers, they don't want all that transaction. EY has dedicated a big chunk of our blockchain research team, about 20 or so resources for the past year and a half, to developing zero knowledge proof additions that can run on the public Ethereum blockchain. So we call this project Nightfall. It's out there on the EY GitHub. It's publicly available. We encourage people to build on it. We have a few challenges out there if you can unencrypt it or track things back. I think there's some bug bounties that are still available. But our goal behind this design to build up software but then put it out in the public domain for folks to leverage it is to help push forward that vision of how we see blockchain connecting businesses, organizations, and people the way that ERPs currently connect within an organization.
Right. So that actually pushes us forward in another direction, right? So all of these examples that we were just going on, Kamal's entity shares data of patients with, let's say, pharma companies. Kat, sharing data across providers and looking at, David is with primarily patients, and you mentioned GSK, David, and you mentioned Merck today. So, I mean, part of where we're trying to push this forward is bringing together to our topic, which is the Trustless collaboration. So talk through that and how you're building that.
Yeah, I mean, it goes right back to the original value prop in Satoshi's white paper for Bitcoin of having unknown actors or known untrusted actors participate in your network. Right. What we're seeing is the technology is evolving at such a pace, I think we'll get over the scalability issues. Privacy is now one of the main things that we're starting to focus on. And so we really like this ability to say, scan a drug or any product for that matter at its point of consumption and then verify that it came from the authorized manufacturer, right? We think things like in emerging markets where you really start tracing these things down into the individual consumption is going to help solve a lot of those problems. To do that, you need a broad network.
Yeah.
And you can't have one that's just based on a central trusted
model.
source.
Yeah.
I mean, I think John highlighted a few
Yeah,
examples
John
of why that
highlighted
doesn't
a few
work.
of those examples. Yeah.
Exactly.
No. Thank you. I want to open up the floor for a few questions from the audience. Thoughts, questions, feedback, comments. Dwayne, please.
I think for a fabulous panel in terms of really opening our minds to the
Thank you.
possibility. I'd maybe go to James first. And are there any working commercial models right now that you would refer to that some of the things you're talking about?
Yeah, I think in life sciences, there are things that people will say are in production that they're working. I wouldn't say there's any giant blockchain-based platforms that everyone is participating in just yet. Some of the other sectors have moved a little bit quicker, as you can imagine. Banks
Synaptic, right? Synaptic.
The Synaptic network. Now that one's interesting, and what I do like about these, and I think you'll start to see these quicker, places where you're trying to produce publicly available information in the most accurate, up-to-date records of that. Are use cases that are out there now that are growing in popularity. So Synaptic Health, it's a simple listing of valid doctor's addresses and office addresses, right? Very hard to come by because that data exists in silos. So they're using, I wish they were using a token curated registry. I'm trying to convince them to go that route. But you'll get these registries of public information out there, and I think you're going to see some of those being the first biggest use cases on public blockchains. We still have to solve the privacy and scalability for some of the other ones.
Sorry, one more here, and then you, please. Could we turn on that microphone, please?
Kamal, you used George's metaphor that whole genome sequencing is like a seatbelt. As a rare disease patient advocate, I'm working to make it be like an infant carrier that hospitals require for you to take your baby home from the hospital. Once newborns leave the hospital, socioeconomic disparities make it very difficult to obtain a diagnosis. And the current newborn screening fails the patients with thousands of genetic conditions outside the 35 that are routinely tested for, as well as healthy babies. Are we headed to this point? And if so, how are we going to get there?
Yeah, I think we're definitely headed in that direction. I think cost and utility is still one of the remaining barriers for a lot of people. I know we talked to a lot of folks who are healthcare providers or payers, and they all agree that we're going to head in that direction where, everyone is sequenced before they even leave the hospital. And I think that's the right direction to go in. But for $1,000 clinical grade whole genome sequencing, we still need costs to come down. A lot of people are being asked to pay for that out of pocket right now. The vast majority of insurance companies aren't going to reimburse that. So there's still a ways to go to prove the utility, I think, of doing that at population scale. But there are projects that are coming online now that are really having compelling arguments that this is a feasible and financially fruitful way to go is to actually sequence everybody.
Thank you.
Thank you, sir. Yeah, please, if you want.
Good morning. Excellent talk. My name is Nick Spring. I head up the life sciences area for a digital transformation company called Alton Calsoft. I was particularly interested, I can't remember which panel member was referring to it, but this whole notion that right now in the genomics field, that basically a number of genomics companies are basically quietly hijacking people's genes without really making it known. It sort of spills over to another area that I'm very interested in, which is also patient consent to do with clinical trials. So the simple question is, how do we make, or how will the public become aware, before it's too late, that they have intrinsically valuable data at their fingertips, both from healthcare records and genomics? Views from the panel.
Please, David.
Okay. Thanks for that question. So this is something people are recognizing now in the world in general. So there are all sorts of services you're using, as you know, that are gathering data from you all the time. And and reselling that because it's valuable. So I think that, for us, one of our ways that we're reaching the public about this is by comparing it with companies like Google and Facebook and others that are doing this in a way that strikes them as uncomfortable. And then recognizing that this goes on with their health data as well. In our case, genomic data, and other companies are dealing with it for other sorts of data. For us, for Kamal and I, one nice thing about genomic data is that as long as it's de-identified, we don't have to worry about HIPAA. So for other sorts of health data, it becomes more complicated, and that's where services like CATS are going to be more valuable. But there's a trend, I think, socially, of recognizing that our data should belong to us, and we should be realizing the value of it not just in the care we're given, but in the reselling and use of that data for basic science.
Yeah, and to add on a little bit to that, there's with like GDPR and growing regulatory overhead, there's a lot more awareness about how data is being used. And it's even worse in healthcare, right? You look at Google, you look at Facebook, they're giving you a free service, and in return, they're monetizing your data. Using most personal genetic companies like 23andMe, it's kind of like, it's as if you were paying Facebook and they were still selling your data, right? So the business models don't really make a lot of sense. It's even worse for like claims data and EHR data. You have companies like Flatiron that their data is essentially being sold for tens of thousands of dollars per patient, right? So we're not talking about, like you look at a lot of the public filings of these big like social media companies, and they're making dollars per person per year. That's like the value of a customer. For healthcare, it can be a lot more than that, right? Especially for patients. And patients and healthcare providers are the ones who are doing the work to curate the data, collect the data, but don't really benefit from it. Even healthcare providers are having de-identified claim data or EHR data being sold that they don't get the benefit from. So I think we need to connect the cycle somehow and make sure everyone's valuing from it and incentivize to create more and help out more.
When it comes to patient consent too, I think there's a driver from the provider perspective, right? So regulations for capturing that patient consent and what you do with it are very complex. They range from state to state. It's hard for hospitals or individual providers to keep track of those things. So I do think there is something to be of value for the provider pushing the consent more formally back onto the patient and capturing that in such a way. And maybe blockchain or some other apps are good ways of doing that. I think Office of Civil Rights in the U.S. in Q1 of this year have doled out something to the tune of $45 million in consent violations, right? Yeah. And they don't even have stuff to look at yet. Yeah. So wait until they really start peeling back some of these things and going after it. I think the push from the providers is going to be significant on that front.
Yeah. Question?
Yeah, hi, I'm Andrew Robson from Sanjeev.
Sir, please.
Andrew Robson, I'm the head of regulatory science and policy at Sanjeev. It was a really great talk, and I think everything you guys said, I really agree with. I'd love to see that happen. We still kind of come up against some of these legal hurdles. And James, actually, I got a question for you, because to the point that your data is, or your genome is something you can actually get compensated for. Really quickly, when you start looking at using that data in a clinical study, we've got IRB rules on remuneration and compensation, and you can almost imagine somebody with a rare disorder might actually have their genome be more valuable than somebody that doesn't, is fortunate not to have that. So, have you thought about this? Are there ways to go through this and to navigate these regs?
One of the things that, and I think it's a nuanced sort of foundational stuff, but it was always just such a light bulb in my head as I started grappling with the implications of using blockchain for tracking this stuff, is the fact that you start to do this at a very granular and very visible level, right? So in relation to some of the regs that are complex, you've now created this very reliable data set that can justify why you made certain decisions in the conditions that you did. A data set that you don't own, right? Something that's kind of provable. And so I think the way that companies are going to start moving towards that, and maybe they're embedded into smart contracts, or maybe they're embedded into analysis after the fact based on that data, but you will have you'll have the documentation as to why you compensated one in one way versus another, and how that was in compliance with your regulations in a way that's much more provable than today.
David, you had a comment?
For David as well,
Yeah.
I think it's also
Yeah.
Yeah, so really right now, the pharmaceutical companies and others who are using 23andMe are getting around the problem of IRBs and consent because of the de-identification of the curated data sets is outside of that. It's a minimal risk study. So if when I was on a IRB and we saw something that was coming in, a study coming in that had de-identified genetic data, it would be considered a minimal risk study. So this is actually going to probably become a problem as people become more savvy and start to think that maybe this sort of data should be regulated by IRBs and ethics, and there should be ethics committee review and consent. I think that'll be a real impediment to science. And going back to the GDPR. GDPR, sorry.
Yeah.
GDPR in California is thinking of similar restrictions. These are real problems from the point of view of open science. I think that GDPR goes too far for a lot of science, and that this is going to be a disincentive to do basic research in the European Union. So we need to try to, this is one of the reasons we did what we did, was to try to stave that off. Create a technology that can solve this instead of regulations that end up impeding the science.
Thanks.
Final thoughts, questions? Okay. Well, thank you. Thanks my panel, esteemed panel, and for all the work you guys did to bring these thought leaderships forward.
Thank you.
Thank you.